Good afternoon. My name is Claire Bradley. I'm the Director of Irish Studies here at the International Institute of Genealogical Studies. But today I have my DNA hat on, as this is the virtual meeting for the DNA students. This is a re-recording of a class that we ran back in March, which had some technical problems. So there's actually not any students here with me when I'm recording it, but it's the same presentation with a little optional extra now. So today's topic is DNA Painter. I'm just going to share my screen briefly, and then we're going to look at some live demonstrations of the website. So DNA Painter is a third-party tool. So it's a website where you use a DNA test that you've taken on one of the main sites, Ancestry, 23andMe, Family Tree DNA, MyHeritage, and so on. And you use data from your autosomal test to do different analyses and modelings on different aspects of it. There's a number of different categories of tool, and I'm going to just take you through some of the main ones today, and we can discuss them in greater detail in another meeting. So the one that you're all going to be familiar with already, I hope, is the Shared Centimorgan project. The Shared Centimorgan project is a crowdsourced tool, and I'm going to just hop over to show you what it looks like. So it's a crowdsourced tool of ranges and averages of DNA shared between different relationships in people. So you can see here on this that yourself is there in the middle, and then it shows you the average share and the range of share with a parent, and the same for with a child, and then for with siblings, nieces and nephews, first cousins, and going all the way out to very distant numbers indeed, eighth cousins, half third cousins, 3 times removed, and so on. And the idea with this is that it was crowdsourced by Blaine Bettinger. People wrote into him using a Google tool saying, well, this is my second cousin, we've both tested, we know who we are already, and we share this amount of DNA. And so this tool allows you to input a number. Let's just take a number at random, 267. And it brings up a percentage guide to what is the most likely thing, that the most likely type of relationships. And you can see for this one that it's quite ambiguous. There's quite a lot of possibilities. Now, if you scroll down, it also has displayed this in the same version as before, but it has grayed out the impossible options now for you. So you see that there's a 61% chance that there are a number of these relationships are the relationship in question, but there's also, excuse me, a 21% chance that it's these relationships and an 18% chance that it's these. So there's quite a lot of options. And how you narrow this down is by looking at how old each of the people involved here is in the DNA match. Is one of them older than the other? Are they roughly the same age? Then we look at their family trees to try and rule in or out possible relationships. You may not also realize that you can also click on these relationships, and it brings you up a chart. And so this chart shows you well, it's a histogram, isn't it? It shows you the number of cases from all the submissions for a first cousin twice removed that fall in this particular range. And so it's saying here, there's where yours fits in this range, but all of these options, and if you actually hover over it, it tells you how many. So you see that between 51 and 100 centimorgans, 63 people reported this for that relationship. So that gives you a bit of extra analyses. Now, you can also use this tool with a second amount. Now, when you're using it with a second amount, I advise strongly that you read the blog posts that are related to this to understand precisely how to do it. But basically, you need to use people who are the same generation. So, for example, if you and your brother had both tested and you had a mystery match, but you both had quite different numbers. So not 87 and 89 centimorgans, but one of you's got 25 and the other one's got 100, for example. You can put in those two things, and it will further refine the options for you. You see, now that I've chosen there something that's particularly ambiguous, of course, but it can help you narrow things down. But the people have to be the same generation, crucially. So you've got to do it with siblings, or you could do it with cousins, for example. And definitely you want to read up on how to do that precisely. So that is the Shared Centimorgan project. It's an enormously valuable tool. I use it every single time I analyze a match. I don't rely on what the testing site tells me. I always look at this to get all of the possibilities. But it's not the only thing you can do on DNA Painter. You can build trees on DNA Painter. And here I have one that I have anonymized from someone else. So this is the tree of a fictional Michael Caine. And I have uploaded this as a GEDCOM, which you can do from your tree. And you can see that when you hover over it, you can put in the information about the person. You can view it, and it says, this person, it gives their dates of birth and death, the names of their parents, and so on. You can also create a new tree using that person as the root person if you wanted to. Now, there's a few options here what you can do. One thing I like is that it's leading people off in shades of colors to help you group them. And you can see that this person has a tree that has got a couple of brick walls. So for example, here, Michael's great-grandparents, there's no details about those people after that. And so you can see at the bottom as well that it gives you a nice 2 of 2 parents, 4 of 4 grandparents, 8 of 8. Here we start to lose some because we don't know the names of these people's parents. And then in this generation, which is quite common in Ireland, where we lose records, he only knows 3 of his 32 3 times great grandparents. Now you can display this in different ways as well. You can do a tree completeness. Now that shows you the same thing, but it gives you percentages. Now, if you were doing this for a younger person, they would have a lot more. If I was to show you the one for my niece, for example, we know quite a lot of the names of her 4 times and 5 times great-grandparents because she is a much younger person. So this is something that's going to change as the generations go by in this century. You can also do it as a fan chart, if you like. If you like to see fan charts as an option, and you can display it as text as well. A thing that I particularly like on this is you can show different DNA paths on it. And some people get confused between what mitochondrial DNA and what X DNA is because they both come from women. So you can actually mark these in. So if I say, I want to see Michael's mitochondrial DNA path, it immediately shows me his mother, her mother, her mother, her mother. That's the mitochondrial line, the matrilineal line. But it's different for the X line. So if I change it to show me the X line, Michael, again, getting it from his mother, but getting X DNA from both her parents and from his paternal great-grandmother there, and coming in on the maternal line, he's getting it from more and more ancestors. So when you're using the X DNA path, it's very useful to actually build yourself a tree for the person you're interested in, because people can forget quite easily which particular ancestors are going to give you the X DNA path. And of course, if Michael was a woman, she would have a different X DNA path to a man, of course. You can also show the Y line, but again, that's very easy. People tend to remember what that is. It's the father's line, and it's usually following your surname if you're Western European ancestry origins. So this is the tree tool, and I really like it. It also prints out very nicely. It does nice screenshots if you want to display them as part of a presentation. I like the colors. They're nice and rainbowy. You can also do something interesting, and this is one of the newer tools. I've just mocked this up as an example, and if you are trying to work out how much of a person's DNA you're able to get from their descendants, you can build a little tree like this. So in this scenario, this is my dad, and my dad is dead. He died before we could take a DNA test, but I'm interested to see how much of my grandfather's DNA we can recreate. So here I've said that there's 2 children for this person, and both of those have taken the DNA test. And Granddad has 4 children. 1 of them has not taken a DNA test because he died before that was possible. 2 of them have taken a DNA test, and the 3rd child has not taken a DNA test yet. So in this instance, it's telling me that we've got 75% of my dad's DNA and 84.375% of his father's DNA coming from 2 of his grandchildren and 2 of his children, who are not obviously the DNA of these grandchildren would be irrelevant here, because you can only get the DNA that your parent had of that parent, so there wouldn't be anything extra. So what it's saying here is that the testers marked we're getting 84.4 approximately of the genome of granddad, but if we were to get the last available child, that would bring us up to 92%. So it's definitely worth trying to get that DNA if you can. So I like this little tool. It's reassured me that I've done as much as I can in terms of recreating my grandparents' DNA at the moment. So we've looked at trees, we've looked at the coverage, and what I'd like to do now is spend the bulk of the time talking about what are the odds. And what are the odds is a magnificent tool of modeling for DNA. And if you're not using it, there's a lot of good larger classes on how to use this. People like Leah Larkin, Michelle Leonard, they often will run workshops on how to use this tool. And there's plenty of YouTube tutorials as well. So this is just a small summary of it for now. And this is the plus version. So there's an original version and there's a plus version. One of the main differences between the original version and the plus version is that the original version used relative probability numbers. So if something was possible, you might get a 1. And then if something else was more possible, it might say 17. And it would say that that was 17 times more likely than the next lowest possibility. However, this time they've reworked it and it now shows percentages instead, and people understand percentages much more. So in this example, which is an anonymized tree that I have created from a client using real DNA matches, I have set it up, and this is one of the key changes from the original to the plus, is that it's easier to set up your research question. So it feeds you this information. You're putting in the information that's in bold. So I am trying to identify the biological father of a woman called Mary Holland, who was born in the year 1934. And I'm using the DNA matches of Mary Holland's child, Elaine. I was also able to say in this case that the mother of Mary Holland was born in 1912, which adds to the detail. If you don't know that detail, don't worry about it. So what I did was I had a tree of people with matches, and I was able to figure out how they were all related to each other. And I was trying to figure out, where does Mary go in this tree? And in this scenario, Tig here at the top was a man who was married twice, and he had children with both of his wives. Now, not all of the children would have been old enough to have a child themselves in 1934. So some of them were eliminated on the grounds that they were a girl and we were looking for a boy. And some of them were eliminated on age grounds. And by age grounds, I'm talking about people who were under 15 when this next generation was born. Of course, it is technically possible that someone might have a child a little bit younger than that, but it's statistically much less likely. But what I identified was that the 2 children born to Tig with his first wife were possible fathers, but he also had 2 sons born with his second wife. The 2 eldest children with his second wife were also both adults in 1934. So all of these people were possible. And as you can see here, when I looked at the DNA matches, all of the DNA matches that I had were from girls in the family. So the 4 boys in question had 2 sisters, Bridget and Annie, who were full sisters of the second boys and half sisters of the first boys. And in this case, we had Michael O'Shea and 2 of his first cousins, and they were all coming in, as you can see, in the high 200s and the low 300s range. And then I also had the child of another different child of Bridget who had tested, and he was 147 centimorgans. And so what you can see here is that Watto, when I gave it these possibilities, it's saying there's pretty even odds that it's one of the 4 boys are all possible. And with the 2 older boys, they're slightly more likely than the 2 younger boys, but they were both still adults as well. And then it also came up with another hypothesis that there was another child that we didn't know about already who could be the father of Mary. Now, what I want to show you is how these things change. So if, for example, I was able to find another child of one of these men, and that person was able to take a test for us, and say we put in, let's just put in 540. Do you see how that changes the probability immediately? And I've just put in a random number there, of course. It has straight away said, Timothy is no longer possible. Barry is now the most possible, and it's gone way up. And now there is only a 1% chance that it's John, and a less than 1% chance that it's Nick, and a 1% chance that it's somebody else. But we're at 98% that it's Barry. So you see how changing those figures can really change the odds. And this is why this tool, you have to be careful when you use it. And when you're using it, I have used this tool very successfully to correctly predict things that I was then able to prove by asking people to take targeted DNA tests. So for example, if Timothy, in this example, did really have another child, we could ask that child to take a test and we would get a result. This is not possible in this case, so we have to look at alternative information. And this is maybe one of the little downsides of Watto, is that it doesn't allow us to take into account DNA matches that come from earlier generations or from Tighe's wives. In this particular case, there was a DNA match to a woman who was a niece of one of Tighe's wives, his first wife. And that dramatically changed the odds that it was one of the boys from the first marriage and not one of the boys from the second marriage. However, if Tighe and his wife were related to each other, which might be possible, well, then that would mess that up as well, because there could be a relationship there. If they were second cousins, then the niece of the wife would also be a distant relation of the husband, and then that would be in play. And that's something that you could use Banyan DNA for, which will be the subject of another talk that we do later on this year. But you can see how important this tool is. And if you're not good at maths, if you're not good at probabilities, it's really great because you just enter in the information. Now, this isn't all to it. And I just want to show you that you see over here, there's more information. So you can import this, you can copy it, you can make a screenshot of it, you can duplicate it, you can do various things. You can color code. There's lots of nice options. They have some sources, and you can use probabilities from 2 different dates, and it's a good idea to read that. And you can also permit relationships with more DNA shared than expected. So this is an attempt to consider whether there might be some pedigree collapse or endogamy, and you can do that. So if I wiggle that around, it doesn't change it much. But you see how it changes it very slightly if I enhance it more. I put it back to 0, it goes back to where we were. And you can change it, but there's more here than is in these options. So if we just go down further, we've got our visual display, which is the one that people are going to be focused on. But it also takes you down here and it gives you more data on why these things are possible. And you see here, hypothesis 3, that an unknown child of Tighe Neely born between these years was the biological father of Mary Holland, and that's about 2 more times likely than the next hypothesis, and so on. And then it gives you the actual calculations of this. So it's got these names of the people, and it's telling us, okay, so in this scenario, this person is this relationship, but it would be this relationship, and so on. And then they work it out. So they're using all of these things combined to come up with these probability percentages, which is really useful. And then down here, it gives you some more detail on how it was worked out. So this is a particularly useful tool. And it does mention here that the statistical data available doesn't allow them to work with situations where people are double cousin relationship. So where two siblings marry 2 siblings, their children are more closely related than normal cousins. 3/4 siblings, where people have quite close shared parentage on the same mother, for example, and then 2 brothers of the fathers, something like that. I think that's what that is. And then, as I said, endogamous ancestry. So the various different options there, and this tool is being improved all of the time. So there's actually, I think there's even a version 3 that is going to be coming later on this year. So this is something that is nice to play around with. And if you haven't used it at all before, my recommendation is to use it on something you already know the answer to, so that you can see how it produces it. So say, for example, you have a known second cousin, set up your tree and say, where does this person fit in? And it should show you, if you've got your DNA matches, you've got a couple of DNA matches from your family, you've got a couple of other ones that are related to both of you, and the person who is your second cousin that you know about, but in this scenario, you pretend you don't know who they are, and see how it shows you what is possible. Because that is a nice, easy way for you to understand it then when you're applying it to a mystery situation. So one of the other tools on DNA Painter, and it really, I'm only going to mention it for a minute because it really requires a longer session than we can do today, which is the chromosome painting. And I'm just setting that up for you now, 1 second. So a chromosome painting then is where you take segments of DNA that you share with individual people and you paint them into your chromosome. I'm just going to share one of mine here. Now, chromosome painting is one of those things that some people really like and some people go, I don't see the use in it. And I'm interested to know where you fall in this. So this is the chromosome map of someone who is deceased. And in this case, I have painted in various DNA matches that I have been able to link to particular ancestral groups of her tree. Now, I'm not going to click on the links because it will display the people's names and I don't want to do that. But you can, here you can see the names of the people where I have, these are ancestral pairs, Michael Joyce, Annie Mahoney, and Lewis Morgan, Elizabeth Griffiths, and so on. And then I have also painted in some where I have an idea of how the person is related, but I don't know for sure. Now, if you want to paint a new match into the chromosome browser, what you do is you find that person in GEDmatch, FTDNA, MyHeritage. It says 23andMe there at the moment, but they have temporarily disabled the chromosome browser after their credential stuffing incident last October. So that information isn't available to you there at the moment. I hope it's going to come back. So you're taking the exact segment. So if you have the DNA match displayed, it will show you that information. And sometimes it's very clear on GEDmatch because they show it to you as you know, chromosome 1, this segment here, from this number to this number, and it's 7 centimorgans, for example. So you just paste that information in and then you save it and it adds it in to your chromosome browser. And over time, you fill in more information on the browser. And the idea is that once you know which people come from which segments attached to which people, you can then infer particular ancestors came from that gave you that segment of DNA. So some people really like it, some people don't like it. I don't use it a huge amount myself, but it does have value for particular projects. So this has just been a very short tour of DNA Painter. There's many more tools on it. It is a website that you can use a certain amount of it for free, and then you can subscribe to use the rest of it. The subscription is, I think, $55 for the year. It's very reasonable if you're interested in it. But I do love that there's a free option of being able to try out various of the tools on it for free. And I highly recommend giving it a go. That's the end of this session today. If you have any questions, as always, you can drop me an email at claire@cbgenealogy.ie or contact me via the school. The school's website is genealogicalstudies.com. And if you're not taking any of our DNA courses at the moment, I highly encourage you to do so. We're in the process of updating them because DNA technology is changing all the time. And I hope to see you at another session soon. Thanks for watching. Bye.